Hi, this is Terry Iverson from CNC Rocks Manufacturing Camp. Today I want to talk a little bit about work holding. On a lathe you have to hold a blank or a part or bar stock and in order to turn, whether it's a manual lathe or a CNC lathe. Remember, CNC is computer numerically controlled. So what I have here is I have work holding devices called collets and a manual chuck. And we'll talk about different ways to hold a part. So I have a 1-inch piece of stock, and I'm going to fit into a 1-inch 5C collet. So the capacity, as the collets get bigger, the capacity on what you hold on increases. But these are all C-series collets. This is a 5C, this is a 16C, this is a 20C, and this is a 25C. And you can see they get bigger as the bigger diameter and longer as the bigger diameter capacity. So for a 1-inch diameter, you can see that, on a couple, 3 of these, I have a 1-inch diameter on all 3, the 5C, 16C, and 20C collet. So from a standpoint of holding a workpiece, this goes inside the spindle. And what happens is you have a mechanical collet closer or draw tube that this threads into, and it pulls back. This angle, if you look at this angle, this is what closes the collet. So as you draw this back into a taper, it then closes down on your bar stock or on your part. So this goes into the collet closer, pulls back. The taper, the head angle of the collet mates with the ID inner diameter angle of the spindle. And that's how a collet operates. There's some other facets we'll talk about in a minute in terms of length control and diameter variation and how that correlates. But for right now, I just want to talk about the capacity and what a collet is. So on a 5C collet, the 5C collet is 1 1/16 capacity. Can't tell you the year it was designed, but it was a long time ago, predominantly for manual machines. On a 16C collet, the capacity is 1 5/8. And if you do the decimal equivalent, that's 1.625. 16 are the first 2 numbers, so hence the name 16C. The C series refers to the pullback and the angle of the collet that allows it to close. On a 20C collet, 2.0 is the capacity in decimal, and so 20 is 2.0, so that hence the name 20C. The 25C collet, I think you know where we're going with this, is 2.5. So once again, the first 2 numbers, 25, hence 25C. So that gives you an idea of the collets. One thing that I'll say is on some CNC lathes, they have collet spindles where like on a manual lathe, this can go right into the spindle. But and there's some CNCs that have, on the machine in our video, that has a collet ready spindle. This 5C collet goes right inside the spindle. It's a more expensive design. It's a more costly design how to design a spindle. So a lot of manufacturers of CNC machines, you'll have to have a collet adaptation chuck. That'll have to bolt onto the spindle, and then the collet will go into the end of the collet adaptation chuck. And it might be 5C, or it might be 16C, and it might be 20C, or it might be 25C. Or there's all different other variations of collets that would go into either the spindle or into the collet adaptation chuck. So speaking of chucks, this is a jaw chuck. The opposite, so to speak, of holding a part in a collet, as you get outside the largest capacity of each collet, then you have to go to a jaw chuck. And a jaw chuck has jaws. And it could have 3 jaw, 4 jaw, 2 jaw, sometimes 6 jaw. Simply refers to the number of jaws that are on the chuck. On a manual machine, one of the videos earlier, on the safety video, I alluded to a chuck key. Well, this is a chuck key. And when I was a youngster in the shop, I put the chuck key in the chuck, was opening and closing the jaws with the chuck key, and then I left the key in the chuck. That's a very bad thing. So what that means is someone walks up to the machine and isn't paying attention, they could turn on the spindle, and then this can go airborne and becomes a projectile, and that's a very dangerous circumstance. So you don't ever want to do that. To be fair, one of my uncles, I believe it was, or my dad, came up behind me and hit me in the back of the head as hard as they could. So I never did that ever again. So on jaw chucks, when you get into CNC machines, you won't have a jaw chuck operate this way. So what you'll have is just to give you an idea, is you'll have a draw tube in the back of the chuck that'll thread to the collet closer. And so that'll draw back, which will then close the jaws of the jaw chuck. So this will thread in. Now, on some machines, you will see they'll have pneumatic closers. On other machines, they will have hydraulic closers. Pneumatic is air, of course, and hydraulic is oil. The smaller machines will normally be pneumatic. The machine in our video is a pneumatic closer, so it's not as powerful for smaller diameter work or more finesse work. But the bigger machines, and certainly the chucking machines, so to speak, they're going to have hydraulics that are holding, heavy components or larger components. But the hydraulic system will tie in to the draw tube, and this will draw this back. And as a result, the jaw on the chuck will close. So one of the other things that I'll talk about is air chucks. Air chucks, what you'll have on an air chuck is instead of a draw tube, you'll actually have an air tube. It's out of brass. It's a smaller diameter than this. But you'll have this coming up to the back of the chuck, and then air will open and close the jaws. So why would you want an air chuck? What reason or what functionality would that bring? Well, with an air draw tube or a hydraulic air tube, sometimes the pressure to move that, open and close that, is too great. And if on a machine, on CNC machine, if you turn it down, you can actually have a safety issue. So the machine will not allow you to go low enough. And on some parts, they're thin-walled. You may want finesse so that you have enough pressure to close on the part, but it'll be lower than what the machine will allow you to operate at. So an air chuck will allow you to grip lightly thin-walled parts very, very accurately. But it won't have the safety built in where into the mechanism of the pneumatics or hydraulics of the machine tool, they'll have the parameters will be set in such a way that you can only go so low as a safety. On an air chuck, that's usually something that you need to be consider is that yes, you can do light operations and light chucking operations, but you also have to consider that it has to hold the part, and that's your responsibility as the setup man to make sure that that's the case. So back to the circumstance of diameter to length. The design of this collet, when you have the diameter, when you're holding on your diameter, if this varies by 1/1000th, then your length, when you close the collet, because remember it's pulling back, that's going to vary 3 times whatever your variation is. So if you vary by 1 thou, your length is going to vary by 3 thou. So that's a common practice. It's something to take into consideration every time you set up a job. And so that's, now they do have workarounds. You can go to a jaw chuck and chuck something where the jaws come straight down. But they also have dead length collets also. And dead length collets has a collet, basically a collet inside of a collet. So the collet moves back and forth to close, but the inner collet closes straight down in a similar fashion to what the jaw chuck does, so that you don't have that variation in length. We could get into a number of other applications in terms of work holding. There's ID chucking for jaw chucks. There's ID expanding collets. for collets, which look way different than this. They're similar to this, but different. And then there's different mechanisms for changeover. There's pads, where you have ID held pads in a collet so that you can change out more quickly. Then you have also quick change collets, where there's heads, where the body's the same, but the head is a separate mechanism. So you have quick change type of work holding for collets. And there's a multitude of other work holding configurations, but this is one of the things you take into account when you sit down to process a part. You need to figure out, how am I going to hold the part? If it's bar stock, it's pretty easy. You hold it in a collet. But if you have a collet-ready machine, it goes right into the spindle. If you don't, then you have to have a collet adaptation chuck. So that kind of runs the gambit of just the basics of work holding. There's one of the things I left out is what they call a mag chuck. Sometimes if an air chuck has too much pressure and you can't hold it accurately enough without distorting it, you have what they call a magnetic chuck, where you have an electrical field that goes, into an electrical circuit where you won't have any jaws at all, and this will be flat. And so there'll be a magnetic field generated, and the part will actually, this is not actually a part, but a magnetic part, brass is not magnetic, will actually just, be drawn and held to the face of the chuck with a magnetic field. That's used many times in grinding. That's used all the time in surface grinding, but that's a conversation for another day.